All right. Yeah, so as I said, there are different formats of data, and because of these different formats, okay, uh, a new terminology basically came up, and that is basically called as big data. Okay, and big data is because of these few factors: volume, velocity, value, variety, veracity, and variability. Okay, let us quickly discuss volume. Volume is basically that data which is stored in different servers at this particular time. Okay, so in very simple terms, let's say you talk about your mobile. If your mobile device is having let's say 100 GB of storage, and 100 GB of storage, out of that 80 GB is filled, so that 80 GB contributes to the volume. Okay, so we have so many web servers, so many data servers, where basically this particular data is being generated and is being stored. Okay, so that contributes to the volume part. Second is variety. Variety is different types of data. As I told, that the data could be structured, the data could be semi-structured, and it could be unstructured. Okay, structured data is easy to understand. The simplest example could be your Excel file. Okay, so you can organize your data in Excel file in the form of rows and columns. Okay, second example could be your database systems. Okay, your RDBMS, MySQL system is there, Oracle database is there, IBM DB2 is there. So database systems, again, example of structured data. Semi-structured, you can have XML files. Semi-structured, you can have JSON format, and then you have log data. Okay, that is also semi-structured. So that is wherever you are able to identify any kind of a pattern, that data you can call it as semi-structured. And then we have unstructured data. Okay, so I'm interacting with you. Okay, so this data, this session has been recorded, this data, so this audio, this video, the text data, so all this is known as unstructured data. Okay, so the data where easily some patterns cannot be identified, okay, that data will be put under unstructured. Okay, this is the second part. Third part is velocity. Velocity is speed at which data is being generated. Okay, so today we see that if we see the smart city concept, so everywhere we will be having cameras, we will be having sensors. So what these devices will do, they will capture data at each and every second. Okay, so they'll be capturing data every moment, so again contributing to generating lots and lots amount of data. Okay, then we have veracity. Okay, veracity is basically the degree to which big data can be trusted. Okay, so this is basically you have the data and you are processing the data, but even after you process the data, what is the authenticity of that data? Is the data correct? Okay, so that is basically called as veracity. Okay, so if the data is not authentic, then still the results we produced are ambiguous, they're not correct, because we still doubt the authenticity of the data. Okay, so that is called as veracity. Next is value. Value basically means that more the data you have, better the results you can produce. A simple example, let's say there are 50 plus 50, 100 people, 50 vote for party A, 50 vote for party B. Okay, and now out of these particular 100 people, only 70 people turned up in the voting mechanism, and party A basically won. Okay, so we saw that 50 from party A did the voting, but from party B, only 20 people turn up and they did the voting. So in actual, if we see that we have equal support for both the parties in actual, but because the data was not collected for all the 100 people, therefore the party A won. Okay, so that is basically now what happened. The value has been degraded. Okay, we could not get the correct result. Okay, why? Because we did not have the complete data. So more the data we will have, we will be able to do more analysis, and better and precise results we will be able to produce. Next we have is veracity. Veracity is variability. Variability is the ways in which big data can be used and formatted. Okay, so this will apply to the applications, where all areas are there where you can apply this big data and the analytics, and basically make use of this particular data. So these six terminologies, they actually make data as big data. Okay, let's quickly move ahead to the next slide. Okay, now basically from where this data comes, or when data is growing, okay, where do we store this particular data? Okay, so one example is databases. All the structured data is basically stored into the databases. Okay, and Then basically apart from databases, okay, we have some file systems also. So databases are more organized, okay, and file systems are little less organized. They have a tree kind of structure. I believe everybody knows about file systems. Like we have directory system, folders are having another level of folders and files. Okay, so file system is there, and we have the database systems. Okay, so this is example of database. Okay, how data is basically being organized in the in different tables. Okay, tabular structure. And with this particular data, if we have this kind of data, how we deal with this data? We have two operations, two kind of basically operations we do. One, we can call it as OLTP, that is called as online transaction processing. And second is called as OLAP, that is online analytical processing. Okay, so this transaction processing every day, let's say I went to a basically ATM machine and I withdraw some amount from there. That is basically a transaction, real-time data processing. Okay, real-time data which is being generated, that is called as OLTP. You book a cake on a particular app, that is called as a transaction. Okay, you transfer some amount to your friend, that is a transaction. Okay, so all these are basically transactions. But let's say you are sitting and you are looking out all your transactions throughout the year. This is called as historical data, and here basically OLAP comes into picture. Okay, online analytical processing comes into picture. Okay, so OLTP is the real-time data which is being generated, especially in the databases, and OLEP is the processing of all the data which has been collected for a longer duration of time. Okay, that could be 1 week's time, 1 month's time, 1 year time, or that can be hundreds of years of time. Okay, the data which has been produced. Okay, so that is called as OLAP. So analysis is the primary purpose, okay, why we basically capture and store the data, because this analysis helps us to improve the business processes, improves the decision making, improves the sales. So everywhere, if we want improvement, this analysis is very much important. Okay, but the challenge with OLAP is that only structured data is not there. We have too many types of data. Okay, so if we want to deal with them, then we basically came up with a lot of different tools. Okay, so now basically let's move ahead and quickly discuss about different terminologies which we are basically listening and discussing in these days. Okay, I believe from last 2 to 3 years, these terminologies have become very popular. They are much being discussed, and a lot of researches are being done, a lot of use cases are being implemented. So let us have a quick discussion over that. Okay, the first and very important terminology is data science. Okay, so let us understand what exactly is data science. Okay, so you can see that the word data and science. Okay, so I will split this word, and in very simple terms let's discuss. Science is basically, just think, what is science? We have been studying, I think from standard first or second, some EVS subject was introduced. Okay, so science we have been studying from a very long time. Okay, so science is study of something. Okay, study of something, or basically exploration of something. Experimentation, that also comes under science. Okay, observation, that also is a process of science. So science is study, exploration, experimentation, observation, okay, discovery. So all this basically is science. But if I say I am studying physical objects, so I'll call it as physics. Okay, if I will say I am studying the geographies of different nations, that will be called as geographical science, geography. Okay, if I will say I'm studying some properties of water, that will be called as chemical science, chemistry. Okay, so therefore this is, I think, is the simplest way to understand what is data science. I am studying data. Okay, I'm exploring data. I'm trying to understand data. I'm trying to apply some formula on the data so that I can get some kind of results. So if you are doing anything with data, you are collecting data, you are basically summarizing data, you are pre-processing data, you are applying some formulas or algorithms on the data, you are visualizing the data, everything will come under data science. All this will come under data science, whatever you do with data. Okay, so this is the simplest way to understand what is data science. Okay, you do something with data, that means you are basically working under data science. All right, so let's have some other definitions given by different magazines or different authors. So one definition says that data science is a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. So many things are included here. So it is a multidisciplinary field. Multidisciplinary field, that means it doesn't apply to a single discipline, single domain. Multidisciplinary field. Okay, And what does it use? It uses scientific methods, it uses processes, it uses algorithms, it also uses systems. Okay, so you can see scientific methods, processes, algorithms, and systems. Okay, so all this basically is used by a data scientist, or data science basically uses all these things for what purpose? To extract knowledge and insights from, okay, structured and unstructured data. So different formats of data we have, and the objective is to extract knowledge and insights from that particular data. Okay, this is the definition of data science. Another definition, that is datarobot.com, they say that data science is the field of study that combines domain expertise, programming skills, and knowledge of maths and statistics to extract meaningful insights from the data. Okay, so objective, if you see in the previous definition, the objective is extract knowledge and insights, and the objective here is to extract meaningful insights. Okay, so the objective, you see, that is same in both of the cases. The objective remains same. Okay, that is extracting some meaningful information, meaningful insights from the data. Okay, and this basically tells that it is a combination of, okay, combination of domain expertise. So SMEs, subject matter experts, are required. Okay, second thing is programming skills. So some IT software guy is also required to build up some programs. And third one is knowledge of maths and statistics. Okay, so mathematics should also be known, and statistics should also be known. Okay, so these three things basically are clubbed together to basically to develop this particular domain that is called as data science. So in turn, these systems generate insights that analysts and business users translate into tangible business value. So that is the objective, that we should be able to use this particular insight or the analysis in our business purpose. Fine. Now, after data science, what do you think will come? Because whatever terminologies I had shown in the agenda, the flow, all that actually comes under data science. So data science is you can say the roof top. Okay, it is the rooftop, and under that only everything else will come. Okay, so after data science, okay, you must have been aware of the terminologies that is called as data mining. Okay, so data mining is the terminology which basically comes after data science. Okay, so before that, let's have a quick history. So how basically it all got evolved. Okay, so you can say that 1763 Thomas Bayes, they came up with basically Bayes theorem. 1805 Adrian Marey, okay, they and Carl Friedrich, okay, they came up with regression analysis. Okay, after that, if you see 1936 Alan Turing, he came up with the universal machine, and he also produced that Turing test. And then in 1943, Warren McLeish and Walter Pitts, they came up with neural networks. Okay, so if you see, nothing new we are discussing, it is age old concept. Okay, but the difference is that at that particular time it was more into research only, it was just into research. But today, in our day-to-day life, in our day-to-day gadgets and applications, all these concepts are being applied. That is the big difference. Okay, so that time it was a concept which was developed, which was not basically being used in everyday life of a human being. But today, if you see, that is a big difference. Implementation is so high today, okay, for all of these concepts, that even you touch up your mobile, you take the Alexa, you take a Siri, whatever you basically speak about, you will find some or the other concept which is basically making a machine intelligent is being used. Okay, so therefore today we are discussing more on a implementation part of it, because as a concept this has been age old. Okay, so as I was telling about data mining, now just try to make the comparison of the definitions. Okay, so data mining is a process of discovering patterns in large data sets involving methods at the intersection of machine learning, statistics, and database systems. Okay, I'll read it again. So it is a process of discovering patterns in large data sets involving methods at the intersection of machine learning, statistics, and database systems. Okay, so we can basically make a comparison of data science and data mining. Okay, there is no much difference. Okay, there is no much difference. Okay, there is similarity in both of them. Okay, but this tells about the process. Okay, what is the process? Discovering patterns in the large data set. Okay, so what is the purpose of discovering patterns? Ultimately ultimately that pattern will help us to that pattern will actually help us to uh, uh, you can say uh, make some kind of analysis. Okay, so Ashwin Joshi want to say something. uh, Let me just Yes, you want to say something, Mr. Ashwin Joshi? You can put it on chat.
Yes,
Okay. Okay. Okay.
yes,
Yeah.
yes.
Yeah. Please.
I tried to put it on a chart, but it is not able to get at your end. It says that Kushal Sharma is not in the meeting. That's why I raise hand. Sorry
Okay.
for
Okay.
interruption.
Yeah. Yeah.
But
Please.
I here want you that do you have any kind of case study for the data science, a
Yes.
small case study?
We will cover
So
that.
can you
Yeah.
share a very small?
Yeah. We'll cover that.
Okay, okay,
Yeah.
okay,
Yeah.
okay. Thanks, thanks.
Okay. All right. So if we see compare both of them, so there is a similarity. It is basically discovering the patterns in large data sets. Okay. And again, it is intersection of machine learning, statistics, and database systems. Okay. Let's quickly move ahead towards another terminology in artificial intelligence. Okay, so after data mining, okay, what we do, we will try to create some algorithms. We will try to use some formulas. And why do we do so? In order to implement some automation. Okay, in order to implement something, we will try to formulate some algorithms. So now the next thing is artificial intelligence. So your data mining algorithm, let's say the very simplest example, your vacuum cleaner. Okay, so if basically you put your algorithm in a vacuum cleaner, then basically that vacuum cleaner can clean out the dust in your room. Okay, it is able to clean out the dust. Okay, so which means that particular device has got little intelligence, and therefore we can call that particular device as intelligent. Okay, but what we did, we had a logic. Okay, that logic is a part of data mining. But what we did implement that logic into a machine, and therefore that machine is able to apply that logic without intervention of human now. Okay, only that single logic it is able to apply. Okay, so that is a small and simple application of artificial intelligence. Similar way, we have automatic washing machines. They are also applications of artificial intelligence. Okay, this was coined by John McCarthy, okay, in 1956. Okay, let's quickly move towards next. Okay, yeah, so basically that time they were actually discussing about thinking machines, artificial intelligence, information processing, and they found this particular term artificial intelligence as best suited term to basically apply it for these kind of applications. Okay, this is definition. Another definition: a theory and development of computer systems to be able to perform tasks normally requiring human intelligence. Okay, such as visual perception, speech recognition, decision making, and translation between languages. Okay, so this is something is the area of artificial intelligence. Okay, but for all this, understand that we will require some kind of algorithms. Okay, and algorithms are a part of data mining. Okay, so if you see that artificial intelligence is a step advanced than just writing algorithms. Okay, we are implementing those algorithms into systems, and systems are basically taking forward, okay, independently executing those algorithms. Okay, another definition: a branch of computer science dealing with simulation of intelligent behavior in computers, the capability of a machine to imitate intelligent human behavior. Okay, these are certain definitions of artificial intelligence. Okay, now basically after artificial intelligence, okay, let's talk about a small kid. Okay, so you all of you must have observed a small kid. Okay, let's say the small kid is walking down the stairs. Okay, so the small kid walking down the stairs. Okay, and he falls down. Okay, now next time what will happen? Next time there are two cases. Case one, that particular kid would resist to go down the stairs. The second chance could be he would sit on the stair, and slowly he will take a step down. Again, by sitting itself, he will take another step down, and he will, come downstairs. Okay, so what happened? Okay, so in case of artificial intelligence, okay, if we see, so intelligence is there in the machine, but is the machine learning also? If the machine starts to learn, then basically that artificial intelligence is now moving towards machine learning. Okay, so machine learning intelligence is there, plus there is a learning capability. Okay, so this is something how basically from data mining, just logics, just algorithms, then automating those logics and algorithms, okay, became artificial intelligence. Then coming to adding up learning part into them, okay, that became the machine learning part. Okay, so Arthur Samuel, they termed this particular coined this term 1959, a field of study that gives computers the ability to learn without being explicitly programmed. Okay, so artificial intelligence, we were just writing a program, we were giving a logic to the machine, and machine was able to do that particular task. But let's say that that particular vacuum cleaner, if we have a new type of dust which that particular machine has never ever observed, it is not in that database also, then will it clean it? No, it won't clean it. Why? Because it is not having the learning capability. But let's say we develop a logic that after every task that machine performs, okay, there would be a feedback mechanism which will be given to machine, and based on the feedback, okay, that feedback would be a reward, okay, that whether it did the right thing or whether it did not do the right thing. Based upon the reward, it will keep on changing, adjusting the actions. So if the machine is able to do this thing, then basically, yes, we will say that machine has got a learning capability. Okay, so after artificial intelligence, if we implement the learning capability in the machines, that is the domain of machine learning. Another definition says that machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Okay, so that means there are certain things inside, okay, I'll call them as parameters. There are certain parameters inside the algorithm itself that basically gets changing, okay, based upon the experience. What is the experience? Experience is some kind of reward or some kind of um, uh, positive reward or some kind of negative reward machine is getting. All right. Now, after machine learning, again, one more specialized concept came into existence that is called as deep learning. This is a subset of machine learning only, but it is specifically focused on the neural networks. Okay, so therefore we call it as like artificial neural network, or basically we call them as deep neural learning. Okay, so this is a subset of machine learning itself. Okay, so I just took you through a lot of concepts which have been basically discussed upon, okay, in data which come under data science only, but they have become specialized terminologies itself, okay, in themselves. Now quickly basically come over these things, okay, which are the learning paradigms which are being used in deep learning, which are being used in machine learning or artificial intelligence, as well as they come under data science. Okay, so we have supervised, ensemble, unsupervised, probabilistic, and reinforcement learning. These 5 types of major learning paradigms we have. Okay, quickly we'll go through them. Okay, supervised learning approach. Okay, here you can see that we have apples. Okay, and we have all the features of apples given. Okay, so apple is also there, all the features of apples are given, and we have a label given there that these features belong to apple. Okay, with this particular data, we basically tell our machine that look at the features. Okay, have you read the features? Okay, these features basically belong to apple. Now look at these features. Okay, these also belong to apple. So what we are doing, we are basically helping our machine to learn from features, as well as the features belong to apple. Okay, so the apple is basically called as label, and the features are called as the input parameters. So input parameters are mapped with a label, and this is something we give it to our machine to learn. Okay, then after learning, now if we give a new parameters to the algorithm or the machine, so machine will make a comparison with all the available parameters, and will see that with whom those parameters are matching most, and what is the output of the existing parameters. If it is apple, machine will tell that this is also an apple. If this is not apple, okay, it doesn't match with apple, it will say it is not an apple. Okay, so in supervised learning, okay, what we do, there is a mapping of input and output pairs. Okay, so input and output is already given. This is a simple equation, you can say y is equal to f of x. Okay, so I'll not go in depth of it. Okay, in supervised learning, now basically classification and regression, these are the 2 types of problems which are covered: classification and regression. Classification is like, for example, if we talk about medical diseases. Okay, so when swine flu came, that time basically doctors were not able to they were classifying it to they were putting it into a normal kind of fever or flu, but it was not so. Even for corona as well, initially, okay, for the very primitive, okay, when the disease was not recognized, it was classified as a normal fever. Okay, so it was wrongly classified. Okay, so classification means based upon some symptoms we can give a particular class, that it is a viral fever, it is just a normal fever. Okay, so we can have different classes. But regression is basically continuous. Okay, continuous means, let's say we all start a marathon. Okay, so in a marathon, I basically cover the let's say 1 kilometer in around uh, just a second. Yeah, so let's say I cover 1 kilometer in 5 minutes. Okay, and the next person covers in 6 minutes, another person covers in 4 minutes, another person covers in 4.5 minutes. Okay, so here we see that there is no basically standard time means there is no standard time that 4 or 5 or 6, only this. Somebody can cover in 10 minutes also, somebody can cover in 9.5 minutes also. So we have so many different continuous values. That is basically called as a regression. Okay, so supervised learning approach is having one classification type of problems, another is basically regression type of problems. So two types of problems are there in case of supervised learning approach. Then we have unsupervised learning approach. In case of unsupervised learning approach, we don't have the output given. Okay, so if we don't have the output given, then how do we deal with data? Okay, so if we don't have the output given, let's say we have been given 3 fruits. Okay, but those are completely new fruits, we have never seen those fruits yet. Okay, then basically we will look at the shape, we look at the size, we look at the color, we look at the taste. So based upon all these parameters, let's say one is sweet, another is sour. Okay, so we will put them apart, that this is sour, this is sweet, but we never knew about those fruits. Okay, so basically in unsupervised learning, we don't have the output data, we just have the inputs, and based on the inputs we have to decide that which are common properties and which are different properties, and based upon that we have to make clustering of the data. Moving towards the next one, ensemble learning. Many times what happens, your one algorithm may be low in performance. Okay, so that algorithm is not able to produce very good results as an individual. So in that case, what you can do is you can basically involve one more algorithm, and you can add one more algorithm, and all these 3 algorithms can work on your data. Okay, so there are different techniques in ensemble. Okay, so they work on data, maybe they work on partial data, they may work on randomly selected data from the main data set. Okay, so there can be different techniques how these 3 algorithms can learn, okay, and work on that data. But the core concept is that you are not having a single algorithm now, you are having more than one algorithm which are working on your data set, and they will work and produce some output. This output then can be combined. Okay, this output can be combined. Let's take example like this. Okay, so here you can see that weight and price example is there. Weight is 10, 20, and weight is 30. Okay, so 3 weights you are able to see here. Okay, so if we have 3 weights here, okay, that is 10, 20, and 30, then we have to identify weight for, let's say, 28 is the 28 kgs is the weight now. Okay, so we have to identify weight for 28 kgs. Okay, so we have, let's say, decision tree, we have regression, we have knn. Okay, so we have or random forest, multiple algorithms we have put here. So one algorithm says 150, another algorithm says 150, one more algorithm is there, it says 200. Okay, so what we did, we applied one mechanism, that is maximum voting mechanism. So maximum voting goes to 150 and 150. So we have been able to create a strong learner here, because so many weak learners are giving some output, and out of them maximum votes are given to a particular value, and that we are taking here as the final value. Okay, right. So basically this is basically example of ensemble learning. Okay, let's quickly move ahead to probabilistic type. So we have another type of learning which is called as probabilistic. So we have seen always that if you toss a coin, then head and tail comes in. Okay, so if head and tail comes in, then basically probability of getting head is 1 by 2, probability of getting tail is 1 by 2. Okay, in this probability concept, conditional probability is very much important. Okay, and with conditional probability we have Bayes theorem which is derived. Okay, so I'm not getting again into the detail of this. Okay, so Bayes theorem is basically example of conditional probabilistic learning. Okay, then now coming to the reinforcement learning. Okay, looking at the picture now, you can see that here we have a dog, okay, and we want to train that particular dog, okay, and what we are training that particular dog to basically have uh, to to properly catch up the ball, okay. So whenever that particular dog is able to catch up the ball, what we will do, we will give him some snacks, and whenever the dog is missing, that time we will not talk with the dog, okay. So what will happen, we cannot talk with dog in basically dog's language, or dog cannot understand our language completely, but with the help of some kind of rewards, we can help the dog to basically understand what objective we want to achieve, okay. So this is a little bit different kind of learning, which is called as reinforcement learning. It works on the kind of rewards we get in real time, okay. Another example, okay, so here if you see certain analogies we will make, okay. So this particular room is the environment where the dog is, okay. First the state was dog is basically ready and prepared to catch the ball, that is one state. Second state is the dog has catched the ball, okay. Another state could be the dog tried to catch the ball, okay, but the ball is not in the hand of dog, it is basically fallen down, okay. That is another state. The kind of actions the dog is taking, okay, he's trying to basically trying to catch with the four legs, okay, the front legs, he's trying to catch up the ball. That is the kind of action he is planning. The kind of strategy he's having a strategy also. As soon as he will see that I'm throwing the ball, he will start catching, okay. So I have used multiple terminologies here, okay, that we have environment, we have a state, we have actions, we have a strategy, okay. So all these are the concepts which fall under reinforcement learning, okay. They all are the concept which fall under reinforcement learning. So I'll not go through this slide because I've explained here the same thing. Let's take example of okay, let's quickly discuss this part and then go through uh, yes, go through an example of reinforcement learning practically. So in reinforcement learning, first step is observation of the environment. Second step is deciding how to act using some strategy, okay. First we observe the environment, then how to act, then okay, we have the strategy. Now act according to the strategy, keep on acting according to the strategy, then receiving a reward or penalty, okay. So either I'll get a positive reward or a negative reward. So negative reward is penalty, okay. Then basically learning from the experiences and refining the strategy, okay, and then iterate until the optimal strategy is found, okay. So examples if you see of these, like the best example is Google Maps, okay. Google Map is the best example. If you reach out to a destination, Google Map always asks you whether you were able to did you find the way correct, okay. Then it will ask you certain things about that particular place. So it keeps on learning. Google Maps keeps on learning, okay. That's the best example of reinforcement learning. Now let us take example of a self-driving cab, okay. So here I'll explain you this, and that basically we will see the implementation of this particular part. So we will create a simulation of a self-driving cab, okay. So this driving cab basically needs to pick up the passenger, drop off the passenger. That is the task of this particular, okay, cab, okay. So now here you can see that this is the kind of environment we will create, okay. The environment, if you see here, we have you can see that we have some positions. Our position here is the R position, and just highlight. So this you can see, this is the R position we have. I'll take some other color so that it is visible, okay. So this is one. This is also not visible, I'm sorry. Let me take white color, okay. So this is one particular place. Okay, yeah. So here you can see this is one place R, this is Y, this is B, and here it is G. Okay, so these are the four basically stops or four places we have. And then you can see that here somebody is standing. Okay, so this is the person which needs to be picked up. Okay, and this is the cab. And here we have some walls. Okay, these are the obstacles. So, and then basically, if you see the diagram, we have divided the whole diagram into metrics so that we can basically decide what kind of actions this particular cab can take. So in this particular position, if you see what kind of actions it can take, it can move towards right, it can move towards front, it can move towards back, but it cannot move towards left side. Okay, so moving towards left side is basically hitting the wall. If this cab is hitting the wall, that means we should be charging some penalty. Okay, we should have some penalty charged. Okay, so that means some negative reward will be given. Okay, as soon as it is moving towards the person, okay, so it will also get some rewards. Okay, so this is the whole environment you are able to see. And in this whole environment, okay, the agent we have is cab, okay, and the cab needs to have some strategy to basically follow. okay, cab has got a set of actions. Okay, once the cab performs one action, it basically reaches out to the next state. Okay, so next state cab will reach is, for example, cab is here, next state would be cab can go into the front. Okay, so uh, we have to calculate the number of possible states cab can go. Okay, so let us basically see this example practically with the help of some sample code. Okay, let us see that. Let me show you the Jupyter notebook now. Okay, I'm changing the sharing screen, so just confirm me if you're able to see the Jupyter notebook screen on the chat window. Yeah, quickly let me
Yes,
know.
we are
Okay,
able
okay, fine.
to.
Yeah, thank you. So this is here I have basically uh, just implemented a small piece of code. So if you look at this particular piece of code, here we have a library called as OpenGym. Okay, so the kind of diagram we discussed, okay, the exactly the same diagram, okay, is basically given by this particular library, which is called as gym. All right. Okay, so if you have if you already have this environment, you can basically install this particular library with the help of this command pip installed pip install cmake gym. Okay, so you can basically install this particular library and then make use of it. Okay, now what I'm doing is with the help of this library, we have a module which is called as taxi v3. Okay, so it can create the same environment. Okay, and it will give it a random state. Okay, let me just execute this one. So here we will be able to see that it will create the environment and it will just help us with that particular environment here. Okay, let it create that environment. Okay, so now you can see that, okay, in the presentation you were able to visually see, okay, exactly the same environment we are able to see here. We have positions, y is one position, r is another position, g is another position, and b is another position. We have walls here, and the yellow spot, that is the taxi. Okay, so this is what we are able to see. Okay, let's move towards the next step. Okay, now in the next we will be able to see we will be able to get that how many actions possible are there and how many state space are there. Let us basically try to get that detail. Okay, so I have possible 6 actions, and here basically possible state space. Okay, all possible 500 types of 500 state space could be there. Okay, they are the all possible state space. Okay, and what are the 6 actions we have? Okay, one is moving forward, moving backward, moving right, moving left. These are the 4. And pick up and drop. Okay, these are the 2 more actions we have. Pick up and drop, these are the 2 more actions. Okay, let's move ahead. Okay, so here basically what we are doing, we are basically with the help of one function encode, we are finalizing the position of the taxi. We are finalizing the position of the taxi. Okay, so taxi row, taxi column, then passenger index we are finalizing, and destination index we are finalizing. Okay, so all these things we are finalizing here. Okay, so let me tell you that the colors also have got a meaning. Okay, so with I'll just explain you what is the meaning of the colors as well. Right. Okay, so here basically we have 3 1 2 0. So 3 1 is the row and column number where taxi will be there. 2 and 0. Okay, so 2 is the passenger index, and 0 is the destination index. Okay, so which, yes, are you saying something? Okay, fine. All right, fine. Okay. Yes, so let us basically render this new environment. Okay, so this is the new environment. Okay, and here basically we have 2 colors. If you see, one is blue and one is pink color, and then B and Z, they have black color. Okay, and taxi position is fixed, okay, as per the environment which we have discussed. This blue color is the pickup location, and R is the drop location. Okay, now basically we will try to run this uh, a particular program without basically creating any kind of reinforcement learning. Okay, so in that case we will see that how many times the taxi has to take steps in order to uh, pick up the particular person from the Y location and drop him to the R location. So here basically sometimes it may be luck factor that that taxi can find it quickly, but sometimes, okay, it will take so many steps which are not at all desired. But how we can get optimal solution? We can get the optimal solution with the help of reinforcement learning. Okay, so let us quickly look upon it. Okay, so this environment.p, this particular tells us, okay, that at state 328, okay, what are the all possible rewards? Okay, what are the all possible rewards that taxi would get? It tells that. Okay, so what kind of steps it can take and what kind of rewards it can get. So this particular anv.p tells that. Okay, so first let us basically see this particular implementation, this small piece of code. Okay, this is basically here we are trying to make the taxi pick up from that particular location and drop in the desired location without basically learning. Okay, so it will randomly basically try to you know it will randomly try to take the steps and go to the pickup location. So let us run this. Okay, so here you can see that time steps taken 2422 and penalties incurred 827. Okay, so 2422 time steps taken. But now next time if I run the same code, then basically here you can see 1355 time steps taken and 435 penalties occurred. Okay, so every time I run this, okay, I will get some different values. Okay, you had seen 198 was also the value. So sometimes it is a luck factor, and most of the time it is taking too much time basically to basically pick up the passenger from a desired location and send that passenger to the particular destination. Okay, now let us clear this output, and now what we will do is we will try to run the same program with the help of reinforcement learning. Okay, so here we will just store the in frames all the rewards and action states. Okay, so this is how it is taking. Okay, so the above, if you see example, okay, without learning, this is how it is trying to navigate, okay, from one place to another place, and then somehow it was able to get into the state Y, and then dropped off that passenger to the desired state, that is R. Okay, you can see that 8,000 steps were taken, so it is the animation, you can see that it is keep on running, okay, till 8,000 steps, and this is without learning. All right, so it is 7,000, it has reached 7,000. Okay, so whatever steps it has taken, all those were recorded. Okay, so 7,726 steps, time steps it has taken. Okay, so I think it is stuck up, the animation is stuck up somehow. All right, so let us do it with the reinforcement part. Okay, so with reinforcement, let me tell you, there is a memory table. Okay, and that memory table is known as Q table. So in memory table, we always keep storing the rewards. Okay, in the memory table we will keep storing the rewards. Okay, whenever there is a positive reward, then basically that step will always be preferred. If there is a negative reward, that step will be neglected. And then we have here three parameters also. One is called as alpha, gamma, and epsilon. Okay, so these are called as hyperparameters. So when we start implementing a learning algorithm, that time we can make an assumption of these particular parameters. But once the algorithm learns from the data sets, then basically these parameters should get minimized. Okay, so hyperparameters are support parameters to make the algorithm learn. So with the help of now reinforcement learning, okay, we are trying to make our model learn, and now you can see that how much time it will take. Okay, Yeah, it is getting executed now. All right. Okay, so yeah, it has been trained now. Okay, so almost 1 minute 50 seconds it has taken. All right, yeah. So now it was getting trained. Okay, so we had set certain time limit that here you can see that for a range of, here we had put this value. Okay, so for these many values it was running. Okay, it has been trained. Now q table, this q table is a memory table. Okay, memory table basically tells us that what kind of rewards basically the taxi will get. Okay, so whether the rewards are positive or negative. Okay, so what kind of rewards the taxi will get, so those things basically will get stored here in the q table. Okay, so yeah, this is the memory table we have set the value as 328 initially. And now let's move ahead. Now evaluate the agent's performance. Yes. So here if you see, so it has taken, so results after 100 episodes. Okay. So average time steps per episode 12.9. Okay. So why it was able to take only 12.9 basically time steps per episode, average time steps, because we were able to make him learn. Okay, with the help of creating a q table. Q table is a memory table which basically stores the rewards. Okay, rewards of basically moving to any step. Basically q table stores the reward, that if you will move right, how much reward you will get, if you will move left, how much reward you will get. So that is the purpose of q table. Okay, therefore now the number of steps, okay, time steps, you will see it is reduced to 12. And initially the same thing, if you see here, in this case, okay, it was never less than, the minimum count we got here was 98. So 98 was the minimum count which we have got. Okay, so this is the difference. Okay, if we implement with the help of learning, if we implement, then in that case basically we will get surely the benefit of learning. Okay, so now basically we can open up for the discussions or questions. Okay, we can have a discussion. So I will just help you with that. You can unmute yourself and you can basically uh, raise your questions and we can discuss. Hope you are getting my voice. Everybody is getting my voice.
Yes.
Yeah, yeah, yeah. Yeah, Pradnya, do you have a question? Do you want to ask something? Okay, okay, fine. So yes, so this was a small implementation of reinforcement learning. Okay, one application. Let's say like you know that a lot of applications are being made. Okay, especially if we say the autopilot cars. Okay, so if we have example of autopilot car, then basically this reinforcement learning will really help that particular autopilot car to decide the uh, best actions to be taken. Okay, now yes, yes, somebody raised the hand. Please please ask. Vishal Borate, please ask. Yes, Vishal, you are raising hand. Do you have any question? Okay, I think by mistake it has been done. Okay, okay. Vishal, do you have any question?
Properly. Start identifying visualization.
All right, all right. Fine then. So coming back to the presentation. All right, yeah. So this was a brief about. I just told you, just to summarize that from the beginning, we started with discussing data science, and then we discussed a lot of terminologies which actually come under data science, and then we discussed about reinforcement learning and how basically we can implement reinforcement learning for a particular CAPS example, taking CAPS example. Now I'm open for discussion. So I request whatever questions, whatever queries you have, or you want to say something, you can unmute yourself. You will be able to unmute and we can have a short discussion.
Kushal sir, I have a question.
Yes, yes.
Can you go to the slides where you have covered the types of learning, supervised, unsupervised?
So these are the learning paradigms. Yes. Is this the slide you are seeing?
Yeah, here I have a question regarding difference between kind of unensemble learning and reinforcement learning. I got the point supervised and unsupervised, but the main three are should be written there.
Okay, okay. Yeah, yeah. Your voice was little breaking, but the question which I have got is that ensemble learning and reinforcement learning, what is the difference between them? This is the question you are asking. Okay, okay, fine. So ensemble learning, the word ensemble means a group. Ensemble itself means a cluster. So the purpose of ensemble learning is that a very layman's example, if we take, let's say we want to move out a big stone from middle of a road. So as an individual, I won't be able to do that. So I'm basically a weak performer there. But if basically 10 such kind of weak performer will come together, they will become a strong performer. Similar way, if we write an algorithm, but that algorithm is having limited capability, or that algorithm works for specific parameter in a better way. Similar way, we have three such algorithms, four such algorithms, which we can utilize for the same particular data set. So we will use all the three or four algorithms, and we will basically give them the data in such a way that it is randomly chunked, randomly divided into smaller pieces and given to each of the algorithms. And after each of those algorithms have given their decisions, their predictions, okay, then basically we will basically take out a combined result out of them. Okay, so I told you one mechanism, that is maximum voting mechanism. So with the help of maximum voting mechanism, we can get the output, and the probability of that output is better, is far more higher than just running one single algorithm. But if we come to reinforcement learning, in reinforcement learning, the primary thing you are able to see is we have in reinforcement learning, we have penalties and rewards. So penalties and rewards, they play a major role. For example, I told you example of Google Maps. Okay, so once you travel from one place to another place, and let's say you had a lot of trouble while basically navigating through that particular road which map has had shown, then basically you can uh, give a feedback there that there were troubles while basically navigating to that particular location. This is a kind of negative reward to the Google map. Okay, so this is a difference in reinforcement learning. You have rewards and penalties, especially that is not there in ensemble learning.
Okay, but in again ensemble learning, is there any combination of supervised and unsupervised algorithm?
Yes, it is possible. It is possible. It is possible.
Okay, fine. Thank you, sir.
Yeah. We can take another 2 to 3 minutes for any kind of questions or discussions we want to have.
Yes, any questions from the participants?
Sir,
Yes, yes.
I wanted to know if the rewards are more, does it mean that the system is doing its work correctly? That is the meaning of that for every application.
Okay. So yeah, I'll explain this point. So there is a concept of greediness. There's a concept of greediness, and then second thing is uh, how much is the time our algorithm is taking to make to find the optimal solution. That is second point. So in our case, greediness is in our case, in the sense, in case of reinforcement learning, greediness is not important. It may happen because rewards, every step some reward is being getting. Okay, the reward may be zero also, but every step there is some reward. Okay, either it is zero, either it is negative, either it is positive. Okay, so if the agent is getting very high rewards immediately in 2 3 steps, but that may or may not lead him to the desired destination. So greediness is not so important. Okay, so getting higher rewards, that may be good if the agent is reaching nearer to the destination, but if with the help of rewards the agent is not reaching towards the destination, then those rewards are not helpful for us. Okay, so along with reward, second thing is timeliness. We cannot basically make our agent freely to move and basically reach the destination when basically out of the time limits. That is another factor. And third is direction. Okay, so your rewards, okay, uh, so in case of this Q learning, what happens if you are taking one step, so you are getting some reward. Q learning will check rewards of next possible steps. Okay, so it will not become greedy. Let's say you are getting 10 reward, and after that in the next 3 steps you are getting 0 0 0 rewards. So this step is not useful for you for long term. For immediate you are getting 10 reward, but you have another option where you are getting 2 reward, but after that you have 3 steps where you can get 15 15 15. Okay, so immediate greediness is not required here. Okay, so I believe my explanation gives you the understanding.
Yes, sir. Little bit. Yes.
Yeah. Okay, how probabilistic learning is different from reinforcement learning. Okay, yeah, so probabilistic learning, if you see, yeah, uh, I request other participants to kindly mute for some time. Okay, okay, fine. Yeah, so probabilistic learning is basically based on probability of one particular condition which has already occurred. Okay, so it says that just a simple example that we are 10 people. Out of 10, 6 people like mango and 6 people like grapes. Okay, so if you see that out of 10 people, there are 2 such people who like mango and grapes both. Okay, 2 or 1, there is one such person who likes both. Okay, so here basically, if we say that I want to understand the question again. There are 6 people who like mango, and there are 6 people who like grapes. Okay, out of 10 people. So this means that 4 people are only liking grapes and 4 people are only liking mangoes. But there is one person. Okay, 4 for 8. Yeah, there are 2 people. There are 2 people who like both. Okay, who like both this also and that also. Now, now basically, given that given that we have brought those people to you who like mango, now tell me how many people like grapes. Okay, so how many people like grapes here? Only one person, because 5 would like only this thing, mangoes, and one person will like grape and mango both in this particular group. Okay, so probability is basically that something has already happened, and out of that we are basically extracting some more information. Okay, so this is how probability works. But reinforcement learning, I already explained, it works on reward maximization. Please tell any application where we can get better solution using ensemble learning. Okay, yes. So yeah, let me give that. Right. So let's take example of some healthcare example. Let's take, okay, again, or because ensemble learning works with most of supervised learning algorithms. Okay, so we can take some supervised learning examples also. Okay, so let's say we have collected the data of certain patients, and we have around 10 parameters. Okay, so 10 parameters we have, where we are applying some supervised learning algorithm. Let's say KNN, K nearest neighbor algorithm we are applying. Okay, and again, taking example of swine flu or COVID-19. Okay, for the first week, the kind of symptoms and the kind of readings we are getting from the patients, they are actually exactly matching up with the kind of existing you can say existing disease. Okay, so here basically the K nearest neighbor is not uh, able to identify that this is basically is not clearly able to identify where basically that particular person should be put into, because it is classifying it wrongly. But let's say because here this is a new disease. Okay, but when we got to know that it is a new disease, when basically we will apply some unsupervised algorithm also, because certain parameters, okay, and some results which we are getting. Okay, so earlier we were not getting those kind of results, so we took certain more parameters. Okay, so that choke, the throat is choking. Okay, so those kind of things. Okay, so certain more parameters we applied, and we added certain more algorithms. Okay, maybe just for the sake of example, K means we applied. Okay, so that gave us some other results. Okay, so if one algorithm is giving some other result, another algorithm is giving another result, then basically we can apply multiple such algorithms, and we can have a voting out of them, and then we can check. Okay, that out of the voting, maximum algorithms are giving one result, so is that result correct? Okay, so many a times out of if you see that those results will be found better. Okay, this is one example I just took out at runtime. And next question is okay, how can you tell us how case-based reinforcement learning works? Okay, so I didn't get case-based. If you want to have an example, so basically I already gave one example is this taxi example. Another example is Google Map example. Okay, how that particular algorithm learns. Let's basically have a very simple uh, example. I'll just show you here. Uh, yeah, so let me just give you a very simple example. Is the blank screen is visible? Blank screen, blank presentation.
Yes, yes.
Okay, so let me just take a very simple example. Yeah, so look at this particular diagram. Okay, so in this particular diagram, if you see, we have 5 different rooms. Okay, this is reinforcement learning. Okay, 5 different rooms are there. Okay, and now let's say you are in room number 0. You start from 0, and you have to reach outside the house. Okay, so you can see that there are 2 ways. One is 4, another is 5. Okay, so if you move out, okay, then so step 1 is from 0 to 4, and from 4 to 5. Okay, because outside is the whole area is called as 5. So one way is 0 to 4, and then 4 to 5. Another way is 0 to 4, 4 to 3, 3 to 1, 1 to 5. Okay, so there are 2 ways. Okay, but basically initially you don't know anything. Okay, initially you don't know anything that when will you get the fifth room? Well, when will you
सिद्धू
get?
आवाज कमी कर.
Yeah, when will you get into the fifth state? Okay, that you don't know. So what we will do is we will create a matrix. Okay, here we will maintain a matrix. Okay, that matrix will contain that if you are moving from, okay, 0 to 4, in that case, okay, how much reward you will get? You will get 0 reward because nothing is being achieved. But if you are moving from 4 to 5, how much reward will you get? I'll give 100 rewards. Okay, complete rewards you will get. But but the possibilities are two. You can move from 4 to 3 as well. So how much reward will you get? Okay, so you will get again 0 reward. Okay, so this is the memory which is stored. Okay, this is the memory which is stored, and next time if another agent is coming from 0, another agent will look whether I should go from 4 to 5 or I should go from 4 to 3. So you know that what decision that another agent will take. Another agent will take 4 to 5 decision only, because here we have 100 reward and 4 to 3 we have 0 reward. Okay, so I believe you understood. So this is a reinforcement learning uh, is a learning algorithm. So first time you may get worst result, but second time you will get better, third time you will get more better, and fifth time you will get best results. Okay, I hope this makes it clear.